Again, this is Maria Overton, and I'm going to take it now from here. This afternoon, I'm going to talk to you guys about traffic analysis, engineering analysis, and traffic noise. So hopefully you didn't have a heavy lunch so you don't fall asleep on me, and I look forward to the receiving questions, and if we don't have time to answer them today, by all means, we'll make time in between presentations. Otherwise, tomorrow afternoon, we will have plenty of time, hopefully, to address any questions you may still have. All right, so let's go with the traffic analysis first. Oh, sorry, there you go. So the traffic analysis in the PD&E Manual, you can find this information in Part 2, Chapter 2. And this chapter provides guidance for preparing the traffic analysis for PD&E studies. So the guidance covers scoping the traffic analysis effort, the traffic data requirements, the analysis methodology, and analysis and documentation required. May I ask how, from the audience, who has performed traffic analysis or is at least familiar with it, traffic analysis and terminology? I'm not sure, Pete, if they can do a raise of hands.
I'm checking right now.
Anyways, I might not be able to see the answers, but okay, so that would have, oh, I see the hands now, sorry. Awesome. So that is very good, because at least I know that you are you're familiar with the terminology. Okay, so computer is being lazy today, all right? So traffic analysis, the definition is an evaluation of the interaction between demand and supply of a transportation facility. Demand being the amount of traffic load that intends to use the facility, and supply, of course, being the capacity of the facility that will handle the demand. The traffic analysis is one of the critical activities for a PD&E study, which forms the basis for developing and evaluating project alternatives. So it is important for the project manager to understand the effort required to successfully perform a traffic analysis. Each transportation project is unique, and the approach for individual projects might differ. So it's not a one-size-fits-all, right? So therefore, when developing the project traffic data and performing the corresponding analysis, the project manager must always balance between the project's goals and objectives, and available schedule and budget, and the complexity of the analysis to be performed. Okay, so the traffic analysis in PD&E includes the development of traffic analysis objectives, select performance measures, determine the analysis approach and select analysis tools, identify the data needed for the analysis, specify collection methods and documentation, perform traffic operational analysis and safety analysis, also perform the document analysis results and assumptions. And of course, I'm sure you're familiar with some of the resources, at least on the department. We have the Traffic Analysis Handbook, Project Traffic Forecasting Handbook, the Traffic Engineering Manual, and the Manual of Uniform Traffic Studies. And in addition to that, the department has adopted the HCM, or the Highway Capacity Manual, and FHWA's Traffic Analysis Toolbox. So what is the objective of the traffic analysis? It is first to reflect the purpose and need for the project and be measurable. Identify the performance problem or goal which the analysis seeks to answer, and it should identify the intended use and decision makers of the traffic analysis results. So before establishing the traffic analysis objectives, the project manager and the project team must review the purpose and need for the project, previously completed planning studies, and the ETDM programming screen summary report, as these documents are essential to determining both the objective and the scope of the traffic analysis. In scoping the traffic analysis, since the PD&E studies vary in size, type, and complexity, the resulting in project traffic analysis with varying levels of details, therefore. So these items here on the screen on this list are items that inform traffic analysis scope. For example, the traffic study limits, the design years, other analysis requirements such as economic air quality and noise analysis, and special needs such as multimodal. In addition, the traffic analysis may have been prepared previously as part of the corridor study, feasibility study, or even an interchange access request, or IAR. In this case, the project manager must review and consider previously completed traffic analysis reports when scoping traffic analysis during PD&E phase. And coordination with the planning office in this instance is very, very important in this step. So what are the performance methods of effectiveness, or MOEs? So the project manager must select the appropriate MOEs based on the needs and context of the project. These help compare the performance of various alternatives, achieve the project's traffic operational objectives. It is important that all stakeholders associated with the project agree to the MOEs and the analysis tools before the project team begins the analysis. This is documented in the traffic analysis methodology. There are various MOEs to choose from. Typical vehicular performance measures include throughput, vehicle miles travel, volume capacity ratio, travel time, travel speed, queue lanes, number stop, density, and of course the most popular that everybody talks about is level of service, right? Hours of congestion, travel time variance, and travel time reliability. And depending on the purpose and need of the project and the problem to be solved, there are other common performance measures that can be used to compare and contrast the performance of various alternatives. This includes safety, environmental, and economic MOEs. And these are typical safety MOEs and environmental and economic MOEs. I'm not going to go specifically through all of them. You can find more detailed information about these in the department's PD&E Manual and other guidance documents. So selecting the right traffic analysis tool, like I said, is really important. And this will, again, vary on a project-by-project basis. And so selecting the right analysis tool should be based on the complexity of the project, the magnitude of the traffic problem, the performance measures, and the limitations of the tools. For this, the Traffic Analysis Handbook should be consulted since it contains guidance for selecting the appropriate tools. So data required for traffic analysis depends on the various factors, such as the project context, the limits, analysis methods, performance MOEs. And the data collection must include the traffic analysis area, which may exceed at times the project limits. The FDOT project manager and the project team must gather all existing available traffic information from FDOT databases, from past studies, prior projects, and other analysis performed within the project area. This information is essential to understanding general knowledge of the project area and identifying any gaps in data that must be included in the data collection plan for the project. The data collection effort can be divided into 3 categories: roadway characteristics, That includes, of course, number of lanes, lane width, bike, the presence of bike and pedestrian facilities, shoulder width, lateral clearances, railroad crossings. Also, the multimodal characteristics of the road, of the facility. That includes volumes, trucks percentages, pedestrian counts. And in addition, operations and safety characteristics. And to list some would be the posted speed, queue locations and lengths, number of crashes and locations, and the severity of crashes. And talking about crashes, this is the most typical length, if you will, of crash data is a total of 5 years of crash data for the crash analysis. So the project traffic forecasting is the process of estimating the future year traffic demand for a given project. The future year, including opening, interim, and planning horizon or design years. Detailed guidance for the traffic forecasting process can be found in the Project Traffic Forecasting Handbook. There are two options for forecasting traffic volumes covered in the handbook, in the Project Traffic Forecasting Handbook. And this is forecasting traffic with a travel demand model or without a travel demand model. And because of limitation of time, we're not going to go into details of this today. There's several available trainings, and again, you can go to the CBTs available from OEM. So the majority of traffic forecasting and analysis should be completed during the PD&E phase. Once the traffic forecast and analysis is completed, the subsequent phases, which would be design and construction, should use the same traffic data for design and operational purposes, such as designing turn lanes, signal timing, or traffic control plans. As the transportation project advances, they may require a reevaluation, and you can find information about this on the part 1, chapter 13 of our manual, and I believe tomorrow we have that as a topic, or maybe later this afternoon. So during the reevaluation, the project manager and the project team must decide if the traffic forecast and analysis prepared for the project needs for the project should be updated. The project manager or PM should verify the validity of traffic forecast by assessing whether there have been changes in conditions or assumptions brought by substantial changes in the economy that may affect driving habits, such as an economic recession or sudden change in gas prices since the project traffic forecast was prepared. Another thing would be substantial changes in land use types or growth rates and patterns within the study area. A good example of this would be a large-scale development, such as sector plans approved near the study area, which have the potential to change traffic generation or travel patterns. In addition, it could also be changed due to substantial changes in the scope of work. For example, the addition of a new alternative that was not previously considered when the traffic model was developed. In this case, model adjustments may be necessary to incorporate changes in trip patterns anticipated within the study area. And substantial changes of the transportation network in the study area, such as construction of new beltways, bypass routes, or express lanes that cause significant changes in demand or trip distribution patterns. Another consideration is the adoption of a new regional traffic demand model when the project traffic is more than 5 years old. If the traffic forecast is more than 5 years old and the MPO has adopted a new LRTP, then the project manager and the traffic analyst should perform a sensitive analysis of revised input and model assumptions to determine the magnitude of differences from prior analysis, and therefore determine the effects on the past project decisions. The reevaluation may require changes to the analysis methodology in order to update the traffic consistent with the latest LRTP. And the project manager should document these decisions, the decisions reached to OEM and other by OEM and other project stakeholders. So if there is no significant change in the traffic forecast, then the study team would simply document the change or no change and the sensitivity analysis results in the project files and proceed with the next phase of the project. If there is a substantial change in the traffic forecast, then the PM must coordinate with OEM to address the need for reevaluating the traffic analysis for the project. And in this instance, the traffic analysis may require changes to the methodology and data inputs and assumptions. So the traffic analysis includes both a capacity analysis and an operational analysis to determine how well the project alternatives are meeting the project purpose and need. Detailed evaluation of project alternatives should only proceed on viable or feasible project alternatives. The PD&E Manual Part 2, Chapter 3, the Engineering Analysis chapter, provides guidance on how to evaluate the alternatives. In order to rationally compare multiple alternatives, the same assumptions and a consistent set of tools should be applied. That's basically to compare apples to apples. All right, so the safety analysis includes the crash history analysis, which is usually 5 years. And this is, of course, within the project limits to assess the existing safety performance and evaluating potential safety implications of a project. Depending on the project context, safety assessment of the project may use the Highway Safety Manual, or HSM, methodologies and their tools. Okay, so now let's talk about one of the technical reports. This is the Project Traffic Analysis Report, or PTAR for short. So the PTAR documents the assumptions, the methods, the traffic forecast, the design traffic, and the results of the traffic analysis for the project in plain language and an easily understood format. It summarizes the data collection effort, the input parameters, the traffic analysis tools, the existing conditions, the development of future traffic forecasts, and traffic operational and safety analysis of the project alternatives. The traffic analysis report decisions regarding the project actions. Therefore, the report should concisely present the results of the traffic analysis in a manner that can be readily understood by a variety of audiences. The discussion of the analysis results should be focused and avoid unnecessary information. Additionally, the report should include text that discusses information presented in tables and figures, maps, diagrams, and those are very helpful. And also the scope and the size of the report depends on the size and complexity of the project. I don't think we can address that enough. And also whether the traffic analysis conducted prior to the PD&E phases are going to be incorporated. Traffic analysis reports for projects that are not complex can include the results of traffic forecasting. The approach to documentation should be included in the scope and agreed upon by the project manager and the project team. For complex projects, traffic forecasting and traffic analysis may be prepared under different project tasks and teams. In such projects, it's recommended that traffic forecasting results and traffic analysis be documented in different technical memorandum or reports. And very important also, the PTAR is one of the reports that is signed and sealed by a professional engineer registered in Florida. Right, so some of the traffic forecasting assumptions. The PTAR must be reviewed and checked for quality and for reasonableness of the results. The view of reasonableness of traffic projections should include examining and comparing observed traffic and historical trends proposed roadway and transit network improvements, and land use projections. Quality control review for traffic analysis results should include reviewing methods and assumptions used to develop the analysis, the inputs, reasonableness of results, and completeness of the results. The assumptions used to prepare the traffic analysis, including traffic projections, should be documented so that the reviewer can easily understand the methodology, input values, analysis results. The traffic analysis assumptions are discussed and agreed upon during the development of the methodology. All right, so this is an outline of what entails or what forms or is included in the PTAR. The report heading and subheadings should effectively delineate the sections appropriate to the level of analysis. The suggested outline for the traffic analysis, which is included in the PD&E Manual, should include the cover sheet of the final report, signed and sealed, like I said, by a professional engineer, the executive summary, the traffic analysis assumptions, in introduction section, which provides a brief description of the project. It includes the project location map, traffic analysis objectives. Then the traffic analysis methodology itself, which describes the tools, software used for the analysis. Then the existing conditions analysis, and this summarizes the balanced turning movement counts for the study intersections or interchanges under existing conditions, and also summarizes operational and safety analysis for the existing conditions, including development and calibration of microsimulation models as applicable. Then also the development of future year traffic forecasting. And also it needs to include the alternative analysis section, which provides a description of the project alternatives, assigning of project traffic volumes to alternatives, and a summary of operational and safety analysis for each project alternative. Also, it needs to include a summary of analysis results. And this section provides a narrative of the advantages and disadvantages of alternatives with respect to the traffic analysis objectives and goals. And finally, the raw data used to prepare the input and analysis summaries is included as an appendix to the PTAR. Other supporting data and information should be attached to the report in the appendix.